Assalamualaikum warahmatullahi wabarakatuh. Okay, today we will learn the new techniques of integration, okay, which is the integration powers of trigonometric function. Okay, before this we have learned the integration by parts. Okay, let's look at the learning outcome for this subtopic. Okay, by the end of this topic, okay, students should be able to integrate the trigonometric powers. Okay, let's look at the integrating trigonometric powers involve the sine and cosine function. Okay, in this session, you should use the trigonometric identities. Okay, which is the first one is sine square x plus cos square x equal to 1. Okay, the second one, sine square x equal to 1 over 2 times 1 minus cos 2x. And the third one is cos square x equal to 1 over 2 times 1 plus cos 2x. Or we can also use the trigonometric identities cos 2x equal to 1 minus 2 sine square x or 2 cos square x minus 1. Okay. Okay, let's look at the tips for integrating this cos and sine function, which involve in this integration involve two functions, sine and cos. Okay, for integrating the sine x to the power of m times cos x to the power of n with respect to x. Okay, if n is an odd number, means the power of cos x is odd number. So we let u equal to sine x. This one. If the power of cos is odd, so we let u equal to sine x. Then split up cos x to the power of n, so that cos x to the power of n equal to cos x to the power of n minus 1 times cos x. We split up this cos x to the power of n, so that the function will have the cos x times cos x to the power of n minus 1. And then use the identity to express the cos x to the power of n minus 1 in terms of sine x. Okay, and the second one, if the power of sine x is odd number, okay, this one, the power of sine x is the odd number. Okay, then we let u equal to cos x. So we split up the sine x to the power of n Okay, this one is sine x to the power of m. Okay, so that the sine x to the power of m, okay, equal to sine x to the power of m minus 1 times sine x, and use the trigonometric identities to express the sine x to the power of m minus 1. Okay, in terms of cos x. Okay, and the last one is if m and n are both even, means the power of sine x and the power of cos x both even. Okay, so we use the half angle formula on both terms. Half angle formula. You have to use the half angle formula. Okay, let's look at the example. Okay, look at this first example. You find the following integral using the suitable substitution. The integration of sine x to the power of 4 times cos x to the power of 3 with respect to dx. Okay, in this case, we know that the cos x, the power of cos x is the odd number, 3, power of 3. So n is the odd number. Then we have to split up the cos x to the power of 3 with cos x to the power of 2 times cos x. We have to split up the power of cos x to the power of 3 into cos x times cos x to the power of 2. Okay, then we apply the trigonometric identities. Okay, for this function, for this cos x to the power of 2. Okay, we apply the trigonometric identities. Number 1. Okay, which is the cos square x, okay, plus sine square x equal to 1. So the cos x square equal to 1 minus sine x square. Sine x square. Okay, then we know that if the power of cos x is the odd number, so we let u equal to sine x. Okay, then we differentiate the function of u with respect to x. So we have du equal to cos x dx. Okay, then we substitute the cos x dx. We substitute with du. We have to rewrite this original function into the u function. Then 1 minus sine x square equal to 1 minus u square. And the sine x to the power of 4 equal to u to the power of 4. Then we expand this function. So we get the simpler new function. Then we can easily integrate this function with respect to u. So we get this answer in terms of u. And the last one, we have to substitute back the function of u equal to sine x. So the final answer must be in terms of sine x. So this one. Okay, let's look at the second example. How to integrate the sine x to the power of 4 with respect to dx. Okay, we know that the power of sine x, the power of sine x is 4. 4 is the even number. So m is even number. Okay, we know that sine x to the power of m and cos x to the power of n. So we know that the m is even number. The sine x, the power for sine x is the even number. Okay, then we have to apply the half angle formula. Using this trigonometric identities, we have to apply the trigonometric identities. Okay, this one we have the integration of sine square x square. So we have to apply the number one. So sine x square equal to 1 over 2 times 1 minus cos 2x. 1 minus cos 2x to the power of 2. Okay, then we have to expand this power of 2. So we have this function 1 over 4 times 1 minus 2 cos 2x plus cos square 2x. Okay, and then we look at the power of cos 2x. This power, the power of cos 2x is also the even number. So we have to apply the half angle formula once again. The half angle formula. So cos for x equal to 2 cos square get 2x minus 1. So you want to find this cos 2 cos 2a, 2 cos 2x equal to 2 cos 4x plus 1 over 2. Cos square 2x. We have this function. So 1 over 2 times 1 plus cos 4x. Then we expand this function. We have this function 1 over 4 integrate 3 over 2, 1 plus 1 over 2, 3 over 2, okay, minus 2 cos 2x plus cos 4x over 2. Okay, then we can simply integrate this. Function. So we have the answer 3 over 2x, okay, minus 2 sine 2x over 2, okay, plus sine 4x over 4. 1 over 2 sine 4x over 4. Then we expand this function. So 3 over 8x minus 1 over 4 sine 2x plus 1 over 32 sine 4x plus c. Okay, let's look at example 3. The integration of sine x to the power of 5 times cos x to the power of 2 dx. Okay, in this case, we know that the sine x to the power of 5 is the odd number. The odd number. We focus on the odd number first. So we have to split up the sine x to the power of 5 into sine x times sine x to the power of 4. We have to split up this form, sine x to the power of 4 times sine x. Okay, then so we want to, then we have to let u equal to, okay, we refer to this function sine x dx. We get the idea of this is the differentiation of the function u. So we let u equal to cos x. Then we differentiate this function u with respect to x. So the u equal to negative sine x dx. Then negative u equal to sine x dx. So we substitute this function sine x dx with negative du. Okay, then we have to modify this function sine x to the power of 4. Okay, we have to use the half right angle triangle. We have to use the half identity, trigonometric identity. Okay, which is this one. Okay, we use the first trigonometric identity, sine square x plus cos square x equal to 1. And so sine square x equal to 1 minus cos square x square. Okay, then we can substitute cos u equal to cos x using this substitution. U equal to cos x. This one. Okay, then we have to expand this function, and we can just simply integrate this function in terms of u with respect to u. Simpler one. This is the simpler one, simpler function. Then we must substitute back u equal to cos x into to get the final answer. So negative cos of 3x over 3 plus so this is the final answer. Okay, next we look at the power of how to integrate the power of tangent and secant function. Okay, in this section you need to know these trigonometric identities. The secant x square equal to 1 plus the tangent x square. Okay, then the tangent x square equal to secant x square minus 1. You have to know this identity, trigonometric identity, in terms of secant and tangent. So secant x square equal to 1 plus tangent x square. Okay, so we look at these techniques. The integration of tangent x to the power of m times the secant x to the power of n. Okay, first we look at if n is the even number. N is the even number, so we have to write this function into this form. Tangent, we have to split up the secant x power of n. We have to split up with secant square x. And then secant times secant n minus 1. And then use the identity secant square x equal to 1 plus tangent square x and substitute u equal to tangent x. We substitute u equal to tangent x because we want to, if we differentiate u with respect to x, du, so we'll get the answer is the negative with secant square x dx. So we can substitute into this function. Okay, if m is the odd number, the tangent x to the power of m is the odd number. This one, the tangent, the power of tangent is the odd number. So we have to rewrite this original function into, so that the function will have the function secant x tangent x. You have to modify this function so that we get the function in terms of secant x tangent x if m is the odd number. You then use the trigonometric identity, the tangent square x equal to secant square x minus 1. Then we substitute u equal to secant x. Okay, look at example 4. Okay, example 4, find the following integrals. Tangent x to the power of 6 times secant x to the power of 4 with respect to dx. Okay, we know that the power for secant x, this one, is the even number. It's the power of 4. It is the even number. Okay, so we have to separate this function into, so that the function will have the secant square x. At the end of the function, we have secant square x dx. So we have to modify this original function. So we get the tangent x power of 6 times get secant square x times secant square x. We have to modify so that the function will have this type of function lah, secant x square. Okay, then we know that, so in this case we can let u equal to the tangent x, so that if we differentiate the function of u, we will get the du equal to secant square x dx, this one, so that we can substitute du equal to secant square x dx into this function. Okay, but the secant x square, we have to modify the secant x square, okay, using this trigonometric identity, this identity. The secant square x equal to 1 plus tangent square x. We have to rewrite this function into tangent square x. So 1 plus tangent x square. Okay, then we substitute this tangent u equal to tangent x. We substitute. So tangent x power of 6 equal to u power of 6 1 plus u power of 2 times du. Then we expand this function. Expand. So we get this function. Then we can simply integrate this function with respect to u. And then after that, the last solution, the last answer, you have to substitute back u with tangent x. You have to express the answer in terms of tangent x. Substitute u with tangent x. Okay, understand? Okay, let's look at example 5. Okay, find the following integrals. Tangent x power of 5 times secant x power of 7 with respect to dx. Okay, in this case, we know that the tangent x is the odd number. M is the odd number. The tangent x, m is the odd number. So we have to split up this original function into, if m is the odd number, we have to split up into secant x tangent x. Split up into secant x tangent x dx. So you have to modify this function lah. So tangent x power of 4 times secant x to the power of 6 times with secant x tangent x dx. Okay, then you have to rewrite this function, this tangent x square. So tangent x square equal to tangent x power of 4. You have to rewrite this function. Okay, then you have to rewrite the tangent x square into the secant square x minus 1. We use the trigonometric identity. This one, the tangent x trigo identity. The tangent square x equal to secant square x minus 1. This one. So we get this function. Okay, then we can use the substitution u equal to secant x. Then we differentiate u with respect to x. We will have du equal to secant x tangent x. We substitute secant x tangent x with du. And then also the other function of secant x, you have to change it with u. Okay, then you have to expand this function, this bracket power of 2. So we have this function. Then you have to to expand again this function into the simplest one. So this is the simplest one in terms of u. Okay, then we can simply integrate this function. Let me check this answer. Okay, the final answer you have to substitute back u with secant x. The final answer. Okay. Okay, next we look at how to integrate the function in terms of cosecant and cotangent, the power of cosecant and cotangent. Cotangent and cosecant x. Okay, can be integrated in the same way as tangent and secant x. We follow the techniques of tangent and secant x. So n is the even number and m is the odd number. So in this case, we want to find the integration of cotangent x to the power of 3 times cosecant x to the power of 3 with respect to the x. Both function is in the odd number. So we have to modify this original function into so that the function will have the cosecant x and cotangent x dx. You have to modify this function, split up the cosecant and cotangent x from each term. So at the end of this function, we have this cosecant x and cotangent x. So the cotangent x squared times cosecant x squared. So times cosecant x, cotangent x dx. Okay, then we have to you have to modify this cotangent x into cosecant x. We use the trigonometric identity where cotangent x squared equal to cosecant x minus 1. Modify this cotangent x into cosecant. This one. Okay, then we let u equal to cosecant x so that if we differentiate u with respect to x, we will have the function of negative cosecant x cotangent x dx. Then negative du equal to cosecant x cotangent x dx. Then we can substitute this one with du. Negative du. So another u cosecant x, you have to substitute with u. So u square minus 1 times u square times negative du. And this one is du. Negative du. So you have to expand this function. You will have u square minus u to the power of 4 du. Then we can simply integrate this function with respect to u. So u to the power of 3 over 3 minus u to the power of 5 over 5 plus c. Then you have to substitute back u with cosecant x. The final answer must be in cosecant x. Okay, let's look at the last example. Okay, for cotangent and cosecant function, integrate the cotangent x power of 4 times cosecant x power of 2 with respect to the x. Okay, so in this case, we know that the function is in the even number. So the even number, so we can let, okay, the cosecant x is the even number, so we can let u equal to cotangent x. You get the idea. So if we differentiate the cotangent x, we will get the answer negative cosecant square x dx. So negative du equal to cosecant square x dx. Then so that we can substitute cosecant x square with negative du. And then this cotangent x, you must substitute with du. Substitute with u, function u. So u power 4 times negative du. Then we can simply integrate this function with respect to du. So we get this answer. And the final answer must be in terms of cotangent x. Okay, so this is the last example. Okay, so the reference is from the Prezi from June IDA 2018. Okay, then I want you to do your tutorial. I will give it later in the Google Classroom. Okay, thank you. See you again. Bye.